Hello and welcome. It is time once again to try to fix something, and today on the workbench of PS4 Slim, Days of Play Edition. Very nice. This particular one, I believe, is a no power. I've got it hooked up back there, as you can see. You press the eject button. Nothing at all. Nothing on the power button. So, hopefully just a power supply problem. So let me get the covers off and we'll see if we can swap this supply out with one of my test ones and see how that goes. And we have this again. Well, that's great. Okay, bottom cover off, and yeah, it's kind of nasty. Lots of nastiness, and I'm a little worried about that right there. Signs of liquid damage. So I wonder how far that went. Alright, I have swapped out the power supply for one of my spare ones. And we're going to show you there's still signs of water damage in the bottom case. So that's concerning. Alright, I've got my spare supply in there. Let's see if we have any more life. I can't quite reach the eject button. No. No signs of life, even with a known good supply. Okay. Water damage may be worse than we thought. I'm going to have to get it all the way down to the motherboard and see what we can find. Alright, the bottom metal shield is off. And this is not looking very pretty. Yeah, we've got a lot of water damage underneath the south bridge area, looks like. And that went on for a while. It looks like it had, there was water under there or something, liquid, and there was power applied to get that much green corrosion going on. So this could be a lost cause. We won't give up yet, though. Well, here we are inside, ready to take a look at this board under the microscope. And from what I've seen so far, it's not looking very pretty. I think that was 3 inductors right there. I want to say that's what that is. There should be 3 chokes there. And they don't look too healthy. And this is all kind of underneath the area of the south bridge. South bridge should be, right underneath these little bypass capacitors you see here. Yeah, let me get that back in focus. I know these are definitely rails going under the south bridge. And, yeah. So that's going to be why we don't have any power signs. I'm sure we're missing some rails under here. Particularly right now. I'm not sure what this supply is, but you can see it looks like a supply voltage coming and then being distributed to 3 different, vias here. So let me get to cleaning and see what's under here. I'm sure I'm going to knock some components off as I do it, though, because some of this stuff looks very loose and questionable. But we need to see what's under all that gunk. So let me get with it here. Okay, I think we found one of our main problems. You see this capacitor right here is physically split open. And if I can get in here again, of course this is ground. I'm in continuity mode. But this end here should not be ground. And I thought I had ground there just a moment ago. Let me scratch through that. No. Doesn't show shorted now, but it did earlier on from over here. Yeah. Something's going on there. Yeah, like that. I think that capacitor's shorted. But it may not be making contact on there anymore, but it was at one time. What about this one over here? Very crunchy under there. I don't think that capacitor's even making contact anymore. But these three inductors here seem to be just fine. 1, 2, 3, all just fine. So another one here. Yeah, these are fine. None of that seems to have opened up. What about this right over here? I don't think that capacitor is doing anything anymore. So let me start in this area. Oops, put my leads together. Sure, it won't take much to take that capacitor off there. Yeah. Nothing left of it. No idea what its value was, but I don't think it was going to tell me either. Okay. And this one here, of course, is not doing anything. Don't think it was going to tell me either. What's under all this? Not much left under there. Just shredding my cotton swab. I wonder. There's those two capacitors. We got some stuff going on up here. Let me set these two to the side, although I don't think I ever get a reading on them since the end caps are gone. Okay. Let's take a look over here, the other side of the board, on this Rich Tech chip here, where a lot of those rails are being developed. Let's see if we have a short on any of the standby rails. That's ground. Nothing. That's ground. That's ground. Okay. Nothing reads shorted on those rails. That's good, I suppose. Haven't really done any cleanup on this side of the board. I am wondering if we've got some vias that have gotten destroyed. And let me see if I can find my 4-pin test plug, such as that. Maybe we can get some power into this thing and see if it has any life to it. Alright, I've got my test 4-pin connector plugged in here, hooked to my bench supply, set for 4.8 volts. Let's just see how much current this thing draws. I think we're ready. Enable. 11 milliamps. And holding 10 milliamps. Yeah, that's not normal. Not normal. Should shoot up to, a couple hundred milliamps at least, then come back down in the 10s or 20 something milliamp range. So, yeah, I don't think our south bridge is working. We need to see if our south bridge is getting all of the supply voltages it needs to work, though. Alright, well, I've been looking at this for a while, and I think I may have finally figured something out. Just trying to figure out the best way to demonstrate it to you. Let's see if we can look under the microscope at the area that we're interested in, around this RT5080. What we're looking for is 5 volts coming in, 4.8, whatever. And I believe it should be coming in, here and down here. And it's not. It's like a volt and winding around like crazy. So where does that come from? Good question. And if you look at the other side, obviously it comes from a via. I'll flip the board over and you can look if I can find it. Holding it like this, I'm not sure that I can. It's hard to do because I'm just looking at my monitor over there. All right. Where is that area? Right in here. Yeah, there we go. It's kind of hard to do this remotely. I'm about a foot away from the microscope. If you look down here, that is the bottom via. And you can see there's nothing left of it. There's nothing to get on this side. So the supply voltage coming in doesn't come from this side of the board. It's coming from an internal layer, which could be a problem for us. And there's where that RT508 is, 5080. And I believe right up here is the top via, which is also corroded away and doesn't seem to go to anything on this side of the board. It's going to an internal layer. So where does it go? If that's, I believe it is 4.8. Let me show you another board I have here. Not the exact same board. It's another slim board, but Sony doesn't totally reinvent the wheel each time. So there's that same via, and there's where the 5069 on this particular board is, and there's the other. Where's the other via? Can't remember where it is. Maybe it's that one. Yeah. On this board, of course, there's no corrosion. I checked with a meter. Where does it come from? And I thought maybe it'd be straight off of the the 4-pin connector over here, if I can get it in the shot. Yeah, right there's where your 5-volt standby comes in, 4.8. You can see right here. That's where it's coming in. It doesn't come straight from there. It's switched in some way. So I was able to find it. If we go over this way, right in there, there's a little MOSFET. And what you have is the 4.8 standby coming in here, and this point over here is what goes on to the RT5069 or 5080, whichever one it is. This is the switched output, and of course this is the control for it. So if I had to, I could run jumper wires back to here, but hopefully I'm going to try to do is I'm going to try to run a wire through both those vias and see if I can make a connection with the internal layer. Do some cleaning out really well with a stiff wire, and lots of flux and try to run some solder through there and see if I can make a connection and restore that internal 4.8 volt connection. I made multiple attempts to restore the connection to the internal layer by using a wire and cleaning it out really well and running solder with flux through the hole along the wire with very limited success. I could make a connection to the upper hole occasionally, but it became apparent it was not going to be reliable at all. So in the end, I ended up just running a bodge wire from the point where it is switched over to the IC, and then another bodge wire from the upper part to the lower part where it entered the IC. Alright, there you can see our jumper wire that we have installed to carry the 4.8 standby over to the RT5080, I think it is. And you can see also where I jumpered from top to bottom there. So that is in place. Let's see what that has done for our current draw. Everything's connected. And if I apply 4.8 volts, nothing. 17 milliamps. Oh, no, Then we go up to 73, 74, 75, and we hold there. That's different. Still not right, but it's different. So, yeah, I'm not sure what's going on there. That should go up to 150, 200 milliamps and then come back down. So I'm not sure what other issues we have going on there. All right, where are we now? Well, looking around this board, I did notice that I did knock some components off during my scrubbing. I can show you here under the microscope. But right in here, there was a diode. And I remember noting, when I started cleaning it up, that the diode looked rough. The pads were obviously corroded away. And there was a resistor over here. And they both have gotten knocked off during my cleaning. Now, the diode I was able to find, it seems to be a type of Schottky diode. But I do have it. I'm going to try to reattach it. It's a tiny little thing. And this resistor, looking at the other board I have here, it has a similar type circuit. That's a 4.7k ohm resistor over here. So I need to find one of those. I should have one in my resistor book. But this right here, this point is attached to the, that goes straight to the battery. Well, if you follow the circuit of that onboard, battery backup for the clock, the positive terminal goes through a resistor, a 1K resistor, and then through a diode. So after that diode over by the battery, that is that exact point right there. So this is the battery voltage coming in. So this is, in some way, it connects to the south bridge, because that's where the clock is maintained. And the problem I'm seeing now is that at that point, I'm seeing like 270 ohms to ground. The battery was dead. The battery that was on here was totally dead. And I popped another one in there that measured like 3 volts. And then I noticed the battery got pulled down to like 2.5 or something. So obviously it was being loaded. And on my other board here, which is not a fully working board, but there's no problem with that part of it. The battery terminal here, this point where the battery is connecting, you measure about 100 k ohms to ground. On this board, I'm getting 270 ohms to ground. And I think I found where that is coming from. If we go right over here, right in there, this pad is connected to that same battery voltage. And you can see that capacitor right there has seen better days. Let me get this in focus. I apologize. All those capacitors on that leg look horrible. So I've got one of those, at least one of those has broken down, I believe. Because I'm getting 270 ohms. And the battery can't sustain that, that much load. So I'm hoping if I can get that fixed, figure out which capacitor or capacitors is bad there, replace that diode and resistor that I knocked off, then we'll see if it acts any different. Alright, I removed 2 of those capacitors that were on that battery input circuit. First one made no difference. The second one, the larger of the 2, made a difference. The resistance went from 270 ohms up into the K ohms. So I did that, and I also reinstalled that diode that I had knocked off. I did not replace the resistor off to the right of it though, because as far as I could tell, there was never a resistor there. Not on this board. Now on the one I've been comparing to, there is. It's a different model, but I did not put anything in there because I just couldn't see where the solder had been. So it's quite likely there was nothing there to begin with. But the diode, I'm pretty sure, did have to be there. So I think I'm hooked back up. Let's see if we've made any change when we apply the 5-volt standby now. Okay, 20, up 176 and back down. That looked more normal. That looked more like what I would call a normal initialization. I wonder if we'll get a beep. Somewhere here I have, oh, here we are, the button board out of that particular chassis out there. Let's see if we can get any kind of a response out of this thing, because that looked like a good initialization of the south bridge. All right, now do we get eject beep? I can get my finger on it. We do. Do we get an attempt to power on? We do. All right, that looked good. That looked good. I think this thing will work now. Let me do a little more cleanup on it and we'll give it a try. All right, we are back out in the garage. I have reassembled this thing enough to hopefully see if it's going to do more than it did before. You can see our lovely bodge wire run across there, carrying our standby 5 volts. I replaced what capacitors I could, cleaned up as much mess as I could. She's not pretty, but does she work? Let's find out. My spare supply is in there. Oh, sounds like there's something in the drive. Bonus? Oh, we're going to get video, aren't we? We're going to get unsupported mode. We're going to reboot for a second, I guess. What do we have as a bonus? Well, it's resetting just as I hit the eject button. Give me a logo, please. All right, we're coming back to life. That's a beautiful sign. I have a white light. I like that. Give me that disc. Clean those rollers. Oh, we have a movie, It. Okay, no game, just a movie. But I think this one is going to make it back. It's going to take its dear sweet time checking that hard drive. I still have to check this power supply. I've got my spare supply in there because I know it works, but I'm guessing this probably works as well. I'll try it out. But yeah, this one is a bit of a mess. I think she's going to come back and work fine. But yeah, that was pretty bad corrosion on that board. Would like to see it give me the full PlayStation logo. Come on. Come on. There we go. 1080p. I think she's going to live. Well, I definitely have some more cleanup to do on this one. Roach remains throughout the chassis. But other than that, I think she's good. Well, I hope you enjoyed that one. Thought it was somewhat interesting, educational. If you did, please give me a thumbs up. And I will see you in the very next repair. So long for now.